Hi guys, welcome to Neuroscience channel. This is our 4th episode. We've done episode 1, we've done episode 2, we've done episode 3, and today is our 4th episode. Today we're talking about what? The bicycloalkanes. But before we start today's class, please I'd like you to subscribe. You see the subscription button there. You click on the subscription button. You can also share with your friends you like, and then at the end of this video class, you can do what? Make your comments there. So today we'll be talking about what? The bicycloalkanes. We've talked about alkanes as what? Saturated what? Hydrocarbons. But today we're talking about the bicycloalkanes. When we talk about bicycloalkanes, we are talking about two rings being joined together. You know, we have what we call the cycloalkanes. The alkanes in its cyclic form. But when we talk about the bicyclo, bi means what? Two rings joined together. So when we choose two rings joined together and they are saturated, we call them what? Bicycloalkanes. So here, this is the structure of bicycloalkane. If you look at this chain here, this bridge here, this is called what? A bridge. Why we have these two carbons here? These two carbons are called bridge head carbons. So this is a typical example of a bicycloalkane. Why? This particular structure, this one here, is a cycloalkane. This is another cycloalkane, and these two cycloalkanes are joined together to form what we call the bicycloalkanes. The bicycloalkanes. So do not be confused. They are called bicycloalkanes because they are not what? Saturated. There are some rings that are joined together which are unsaturated. You might see some bonds, maybe double bonds. Those ones are not bicycloalkanes. But this one, they are bicyclo basically because we have two cyclic compounds joined together, and secondly, these two cyclic compounds are what? They are saturated. They have just what? One bond. We have one bond, one bond, one bond, one bond, one bond. So this is what we call bicycloalkanes. So in today's class, we are going to learn how to name these words bicycloalkanes, because most students don't know how to name what? Bicycloalkanes. They can actually name alkanes, they can name branched and unbranched alkanes, they can also name the cycloalkanes, but when it comes to bicycloalkanes, they become what? Confused. So for the purpose of today's class, I would like you to listen carefully so that at the end of today's class, you will be able to name bicycloalkanes. So we have some bicycloalkanes here. The nomenclature was bicycloalkanes. If you have a good idea of how to name alkanes and cycloalkanes, you should be able to name bicycloalkanes too. Very simple. So in naming bicycloalkanes, the first thing you have to do is to identify what we call the bridge head carbons. The bridge head carbons. The carbons joining the two cyclic structure. That is the first thing you have to do. You have to identify. So if you want to name this bicycloalkane, what you have to do is to identify the bridge head carbon. So this is the bridge head carbon. This is what bridge head carbon. While this other chain here, this line here, is what we call the bridge. So actually identify the bridge head carbons. We have two bridge head carbons, one and what? Two. So these bridge head carbons, they are joining what? This structure and this structure. So how then do we name this structure? After identifying this, then we count the number of carbons on the first structure and the number of carbons on the second structure. On this first structure, we are moving this way to this way. We are going to count carbon 1, carbon 2, carbon 3, and carbon 4. That is for this structure. Why? If we are moving from this direction to this direction, we have what? Carbon 1, carbon 2, and carbon 3. And then on this bridge, there is no carbon. Only what we have is the bridge head carbon. How then do we name this bicycloalkane? Because we are having two structures here. We put our bi. Bi stands for 2. And then we put our bicyclic. bicyclic because they are in their cyclic form. And then we have how many carbons here? 1, 2, 3, 4. That is on the first structure. We have 4 carbons. And then on the second structure we have 1, 2, 3. We have what? 3 what? Carbon. And in the bridge we don't have any carbon here. So we have what? 0. The next thing will be counting the number of carbons in the structure. 4. We have 4 carbons in the first structure plus 3 carbons on the second structure plus what? 2 bridge head carbons. So we have 4 plus 3 which is 7 plus 2 which is what? 9. And 9 stands for what? Non-A. Therefore, the name of this compound will be bicyclic 4,3,0 non-A. It is 4 because the first structure has 4 carbons, 3 because the second structure has 3 carbons, and 0 because this year does not have any other carbon with it apart from the 2 bridge-headed carbons. So you know what bicyclic 4,3,0 non-A. Bi because we have 2 cyclic compounds. Non-A because altogether we have 9 carbons. This is how we know what bicycloalkane. Let's name this. This is another example of what a bicycloalkane. So I said, if you want to name a bicycloalkane, the first thing you do is to identify the bridge head carbons. So let's identify the bridge head carbons here. We have one bridge head carbon here, and we have another bridge head carbon here. So we identify the 2 bridge head carbons. To identify bridge head carbons, you have to note the 2 carbons joining this structure. The carbons joining these 2 different structures are what we call the bridge head carbons. So we're able to identify the bridge head carbon. The next thing we do is to count the number of carbons on the first structure and on the second structure. So if we are moving from this direction, this bridge head carbon, to this one, we are going to meet what? 2 carbons, 1 and 2, which is 2. If we also move from this direction here to here, we meet another 2 carbons, 1 and 2, which is 2. And then on this bridge head carbon, we meet just one single carbon here, which is what? 1. Unlike this, where we have nothing, here we have one carbon on the bridge head carbon. So we have here we have 2, and we have what? 1. Because we have 2 cyclic compounds joined together, 2 cycloalkanes joined together, we call it what? Bicyclic. And then what will be the longest chain? The longest chain will be the total number of carbons here plus the number of bridge head carbons. So we have 2 plus 2, 4 plus 1, 5 plus 2 bridge head carbons, making it what? 7. So we count the number of carbons here. 1, 2, 3, 4, 5. We have 1, 2, 3, 4, 5, 6 and what? 7. And 7 stands for what? Heptane. 7 stands for heptane. So the name of this compound will be bicyclic 2,2,1 heptane. It is bicyclic because we have 2 cycloalkanes joined together. It is 2 because the first structure has 2 carbons, the second structure has 2 carbons, and between the 2 bridge head carbons we have what? 1 carbon at the center. The total number of carbon is 7. That is why it's called what? Heptane. Bicyclic 2,2,1 heptane. Let's move to the next structure. This one looks somehow complicated, but if you play the same way, it is also very, very simple. So let's name this structure. The first thing is to identify what the bridge head carbons. What are the bridge head carbons here? We have this, and we have what? This, joining 3 structures. 1, 2, and what? 3. So if you are moving from this direction to this, we have what? 2 carbons, right? We have 1 and what? 2. We have 2 here. If you are moving from this, we have 1, and then this way, we have 1, 2, and 3. So we have 1, 2, we have 1, we have 1, 2, and 3. This is not a carbon combination, but this is a straight line. This is a straight line. So we have 1, 2, we have 2, we have 1, we have 1, 2, and 3. So what we do, we are going to name it in descending order. We will name it what? In descending order. So in descending order, we have what? 3. This one has, this structure has 3 carbons. To be 3, this is 3, let's write it here, 3. And then in descending order, the next will be 2, and the last will be 1. We put it in the brackets. This is a bicycle, so we put bicycle. This is bicycle. Okay, let's put it in the very box. Let's put it in the very box, please. So this is bicycle. This is bicycle. And then what is the total number of carbon here? We have 3 plus 2, 5. Plus 1, 6, plus the 2 bridge-shaded carbon is what? 8. So if we count 1, 2, 3, 4, 5, 6, 7, and what? 8. And 8 stands for what? Octane. 8 stands for octane. So the name of this compound will be bicycle 3, 2, 1 octane. It is bicycle because we have 2 cycloalkanes. We have these 3 carbons on this particular structure, 1, 2, 3. We have 2 carbons here, and we have what? 1 carbon here. That is why we are having bicycle 3, 2, 1 octane. Let's name this other structure. This is also the bicycloalkane. Using the same pattern, how do we name this bicycloalkane? How do we name this bicycloalkane? Let's put it very well. This is slide here. The new carbon here is slide. Before this, identify what? The bridge-shaped carbon. If you identify this another, this is bridge-shaped carbon. This is another bridge-shaped carbon. So if you are moving from this direction to this direction, we are going to meet 4th carbon and 2nd carbon, 2 carbons. If you are moving from here to here, from here to here, just put 1 carbon. And then in between the bridge-head carbons, we have just 1 carbon too. Moving from here to here, we have 2 carbons, 1, 2. Moving from here to here, we have 1 carbon, 1. And then between the bridge-head carbons, we have just 1 carbon. We put our brackets and then write out our bicycle. What then is the longest chain? The longest chain is counting the number of carbons here, adding everything together, plus the 2 bridge-head carbons. 2 plus 1 is 3, plus 1 is 4, plus 2 bridge-head carbons was 6. So we have 1, 2, 3, 4, 5, and what? 6. And 6 carbon stands for what? Hexane. So the name of this compound will be bicycle 2,1,1 hexane. It is bicycle because we have 2 cycloalkanes. We have 2 carbon on this part of the structure. We have 1 carbon on this part of the structure, and we have 1 carbon between the 2 bridge carbons. Bicycle 2,1,1 hexane. Finally, how do we name this bicycle compound or this bicycloalkane? It is also very simple. Do not be confused or do not be afraid because of the complexity of the structure. If you follow the pattern, you will get it. The first thing to do was identify the bridge-head carbons. Let's identify the bridge-head carbons here. This and what? And this. are joining these structures. So if we are moving from here to this direction, we have 1 carbon and 2 carbon. For here, we have 1 and 2, and then for here, we have what? 1 and what? 2. 1, 2, 1, 2, and 1 what? 2. So we have 2, okay, let's put it down, it will be very clear. We have 2, 2, and what? 2 in a bracket. It is a bicycle, it is a bicycle alkane. So we put bicycle. Bicyclic, and then let's count the total number of carbons. 1, 2, 3, 4, 5, 6, 7, and what? 8. 8 stands for what? 3. So the name of this compound will be bicycle 2, 2, 2 what? Octane. Bicycle 2, 2, 2 octane. So we've learned how to name what? Bicycle what? Alkanes, using our simple idea of alkanes and cycle what? Alkanes. If you are able to follow the simple pattern or the simple rules I said there, you'll be able to name any other bicycle what? Alkane. But do not be confused. They are called bicycle alkanes because we have 2 cycle alkanes joined together. And why are they called cycle alkanes? Because they are what? Saturated. They have just 1 bond. If they have more than 1 bond, then they are unsaturated. They are no longer what? Bicyclic. They are no longer bicyclic alkanes. We now have what we call the aromatic hydrocarbons. Aromatic hydrocarbons, you see 3, 4 structures joined together. Those ones, they are different from these. They have more than 1 bond, so they are unsaturated. But these ones, the ones we talk about today, they have just 1 single bond, and that is why we call them what? Bicyclic alkanes. So therefore, whenever you see a bicyclic alkane, do not be confused. Follow the simple pattern and rule that we taught in this class, and then you'll be able to name any bicyclic alkane. Please do well to subscribe to our channel so you get more notifications on different classes when they come up. Thank you.